Here is section 1.1.8, which is function notation. So the first thing I'm going to do is define what a function is. And then we'll see how to use it in practice. So a function is a mathematical relation in which for every value of x, it would be nice if I made my t's look like t's. A function is a mathematical relation in which for every value of x, there is one and only one value of y. Okay, so that's what we're going to be talking about now. And the first thing I'd like to do is give you two sets of numbers. So first of all, can everybody mute? Because there are some people that are not muted and I hear sounds and it's distracting. Okay, very good. Thank you very much. Okay, so here are two sets. First, right over here, I'm going to create okay, so let's see. So that's one. And this will be, so this is, let's call this A, and let's call this B. Now, a few, nomenclatures. So first of all, this will be the X and that will be the Y in the definition. But this is also called sometimes the input, and this is called the output. These values of X are known as the domain. The numbers over here represent the range. Same thing over there, but we'll get to that in a little while. Well, let's do it now because I'm going to be making a comparison here. So again, the input and the output. The domain and the range. So these are two relations among X and Y. One of them is a function according to the definition, and one of them is not. Can anybody tell us, in the first case, whether this is a function or not, and the reason why?
I think A is a function
Christian.
because
Well, Christian, I usually call on people, so Christian, yes, go ahead.
okay, I think A is a function because functions must have one input and one output because one input can't be associated to two things at the same time.
And this has that characteristic?
Yes, because one is to four, two is to four, and three is to five. On B, one is at two output.
Well, let's talk about B. Talk about that again.
On B, the one input is connected to four and five.
So therefore, one value does not go to one value of X does not go to one value of Y. A value of X actually goes to two values, right?
Yeah.
Good, you're exactly right. So this is a function. And this is not a function. Good, and let me repeat that again for the class. So, in other words, the definition is that for every value of X, there'll be one value of Y. So for the one, we have a 4, and we have no, and not a 5. So that works very, very nicely. One value of X, one value of Y. One value of X, one value of Y. Even though two values of Y stem from, two values of X rather, go to the same value of Y, each value only goes to one value of Y. As opposed to here, where we have a 1 going to two values of X. Therefore, just this characteristic right over here makes it not a function. And there's no characteristic like that over there. Okay, good. Very good. Thank you. All right, let's look at graphs. So this is like mathematical sets that are, represented here. But let's look at a graph. Like, remember when we were doing the circle? Is the circle a function? Is the graph of a circle a function?
Yes.
Tamika? Yes,
Yes.
it is a function. Explain why.
Because each value of X has a different value of Y, or has its own value of Y.
Yeah, but that's not the definition. The definition is for every value of X, there's one and only one value of Y.
Oh,
So,
because it's not um, excuse me. So like a straight line is not a function, is that right?
well, forget about a straight line. Let's look at this. This is a circle that we did last week.
Well, I understand it's not a function, but I'm having a hard time explaining why.
Okay, you
Yeah.
understand now because you said it was a function. Now you're saying it's not a function.
Sorry, no, I understand it is a function, but what I don't understand how to explain it.
All right. Does anybody know? Can anybody else give an opinion on this matter?
I wasn't
Question
here
again?
last week. Yeah, I wasn't here last week, but I remember learning that this isn't a function because if you graph a circle, if you do the vertical line test, one output could have multiple inputs on the vertical line test, so it's not a function.
So Christian is a little bit ahead of the game because he's referring to something called the vertical line test. The vertical line test is what you do if you have the graph of a function and you draw a vertical line. If the vertical line touches the graph at 2 points, which it obviously does, then therefore it is not a function. So the vertical line test is really a very important test. So if at any point, like, if you wanted to, you could have graphed a straight line right over here. And the straight line would have touched the circle at one point, but you have to do it sort of all over the place and see that every straight line, every vertical line that you draw touches the graph at 2 points. If it touches the graph at 2 points, therefore it is not a function. As opposed to this graph, one of my favorites, which we will not be doing for a long time, but we will be doing. This is called a sine function, S-I-N-E, y equals sine x. Is this a function? So not Christian and not Tamika, but somebody else tell us, is this a function?
Yes.
Mia, yes. So you're saying it is a function Explain why.
Because it passes the vertical line test.
Good. That's it. That's all you have to say. Very good. If you draw a vertical line, and the vertical line, is going through a value of X here. So what you're basically doing is what we did up here. You're saying, well, for every value of X, how many values of Y does it touch? Only one value. There it is. These are the X's and these are the Y's. So for every value of X, and let's keep doing it. Let's do it over here. Yes, that's good. Let's do it over there. Yes, that's good. So this is a function because for every value of X, there's only one value of Y. Okay, and there are some, we're going to be doing some very weird graphs over the course of the semester, especially in chapter 2, where, things look weird. Is this a function?
I would say yes, because you just explained if you put a value into X, you're gonna get something for your Y.
Yeah, but the problem is,
I think multiple X has the same Y, yeah.
for a value of X, you're going to get 1, 2, 3, 4 values of Y. Therefore, this is not a function. This is not a function because for every value, well, for some values of X, obviously this one, you draw a vertical line, it's going to touch the graph at 4 different points. So this is not a function. Okay, and that's all I want to say about that. Does anybody have a question? Just on the basic definition of a function. All right, let's
Sorry, so if I just wanted to understand. So you said if you're putting in a value for your X, for your Y, you only need one Y.
exactly.
And if you put a value for the other one, the one next to it, the third graph, you have 3 different Y's, which is why it's not.
4 different Y's.
Oh my God. Okay, got it. Thank you.
You got 1 here, 1 there, 1 there, and 1 there. Okay, but you've gotten the point. I mean, that's the point. You just didn't realize there were 4, there were 3. Yes, that's exactly right. Okay? All righty. Let's talk about, so, again, let's go back up here for a moment. These values are the domain. The X's are the domain and the Y's are the range. Now keep that in mind as we now talk about domain. But the domain is the set of X's, is the set of values of X that we are allowed to use. We are allowed to use. For example, if I give you a function like y equals, and somebody mentioned this recently, somebody mentioned this when we were talking about functions or not, that linear relations are always going to be functions. And that's true, because for every value of X, there's only one value of Y. The domain is talking about all the values we're allowed to substitute in, and the answer is we're allowed to substitute all values of X. In terms of interval notation, remember interval notation? In terms of interval notation, this is how you would write it: negative infinity to infinity. This tells us that this simply means that all values of X are contained in the domain. And in other words, all real numbers. And another way of writing that is to write real numbers using that notation. Okay, so a linear function has a domain of all real numbers, as opposed to, is that true for that relation? Not saying it's a function. As a matter of fact, there is a basic problem here. Does anybody know what that basic problem is? What value of x can we not use in this situation?
0,
Good,
because you can divide by 0.
right? You cannot divide by 0. So we would say that from negative infinity to 0, and then after 0 to infinity. This is the domain for this function. On the number line, you could see it even more clearly. You could see that, 1, 2, well, the values up to infinity, to negative infinity, that if we come this way, and we're like, just meandering along, having a good time, when you get to 0, you cannot substitute 0 in here. Therefore, you put a circle around that, and then pick it up on the other side and continue going in this direction. Okay? So this is the domain right here. Negative infinity to 0. But when you get to 0, you jump over 0. So what we're doing in this situation is we're restricting the domain. We're restricting the domain. This is a domain, but only if we restrict it so that x is not included. So if I say to you, what is the domain for something like this, you would do this. What's the problem here? Because what values of x is the domain for this particular relation? What's the problem here? The problem is x cannot equal a negative number. You can't have the square root of a negative number in the number system that we're currently using. There is a number system that you can use to define this, but when we talk about real numbers, like 1, 2, 3, 4, like fractions, even like a half or a third, then there's no negative number that you could substitute for x, which will satisfy that. Therefore, we say that the domain will be from 0 to infinity, and that's it. Everything less than 0 will not work. So if you look at this in terms of some sample values, only zeros, the absolute value of, the square root of 0 is equal to 0. So that works fine. And then every number that's positive will work fine. So all these numbers represent the domain.
But won't it just become positive when you take the square root of the negative number?
What's this? What does square root mean? The square root of 4 is 2, right? The square root of 9 is 3. The square root of 2 is 1.4. But what's the square root of negative 3? What number times itself will give you negative 3? Get it?
Yeah, thank you.
Okay. So no negative numbers are part of this domain. Indicate the domain for the following. I'm gonna give you problems and you have to indicate the domain. In the first problem, we have a linear equation. Whenever you have a linear equation, the domain will always be negative infinity to infinity. That's it. Or if you would like, you could use this symbol. This also means all real numbers. This means all real numbers as well. Okay, so that's out of the way. Now, here,
Can I answer?
go ahead, Bar, go ahead.
Is
Whoa,
it,
whoa, whoa, whoa.
Yeah.
Nazima, do you have a problem? You have a
Yeah, yeah.
question?
So for number one, right? So you know how because I watched your video and you said you have to show work on the exam. So if we were to just put for number one, infinity, do we like show the work how we got there?
I
Like,
mean, no, not in this case.
oh, okay, that's perfect.
First of
Okay.
all, thank you for reading my, instructions so well. That's number one. But number two, it's not necessary to show work here because it's kind of something you would know automatically. That every linear equation will have a domain equal to this. That's it. That's all you have to do. Okay, are there any other questions on this before we move on?
It's that's just the rule, like for that.
Yeah, yes, it exactly. It's just a rule. Okay, so are there any more questions about problem one? Okay, then Bar, go ahead.
is it all the numbers besides 3? So negative infinity to 3 and then 3 to infinity?
Okay, but for this, I want to see work.
Because 3 will give you 0 and then you'll have to divide by 0. So it's all the
You know,
numbers besides of
that's
3.
good enough. That's good enough.
Yeah.
So in other words, you've told us the answer, which is that it can't be 3. It could be negative infinity to 3, and then when you get to 3, you skip over it and you go to infinity, right?
Yeah.
Okay, now I would have said, x minus 3 is not equal to 0. That's
Oh, you
basically
can
what we're
answer that
looking
one.
for. Well, what we're looking for is that the denominator is not equal to 0. So this
Mm.
is really the work, when I say show your work, this is what I meant. Do this, and this will hopefully give us that. So therefore, x is not equal to 3, which translates perfectly into that interval notation answer. But that's
So
good,
do you have to give both the notation and the?
If you gave me this answer, I would
Mhm.
give you full credit because, I mean, it's obvious that x can't equal 3, because
Yeah.
3 minus 3 equals 0. I mean, if you want to, you could say, all right, well, obviously, this is not going to work because you can't have 1 over 0. And therefore, from here, you go to there, but it's not necessary.
Can I answer C too?
No, you can't. Somebody else has to do it. There are other
All right.
people here, but thank you, Boran. That was great. That
Mhm.
was great. Now, can somebody else answer problem C? Well, going once. Tamika.
Yeah, so x can't be negative, or excuse me,
Okay,
it can be
so
negative. Sorry, it can be negative, but it can't be negative anything less than negative
well, wait a minute.
2.
This whole thing. Talk about the whole thing in there. Everything underneath the radical sign. It's called a radical sign.
Yeah, so that's
Thing
what I mean.
underneath the radical sign, right?
Can't be negative. So negative
Good.
2 would work.
So everything that is greater than or equal to what?
To negative 3 would work. Yeah, because it can be 0.
This has to be greater than or equal to 0.
Yes, that's what I'm saying. So -3 plus 3 is 0.
Yeah, but I'm trying to do it in a certain way.
I
and I'm
see,
saying
okay.
that the number underneath the radical sign
I see what you're saying.
has to be greater
Has to be
than
0,
or
greater,
equal
0
to
or
0.
greater. Yes,
So therefore, X has to be greater than or equal to
to
negative.
-3.
And
yeah.
therefore, so therefore, in
bracket-
integral notation, that's
bracket -3
-3. Go ahead.
to infinity.
Very good. Okay, so it's obviously, the problem there was that you knew exactly what you were talking about, but I was trying to.
To show the work. Yeah,
yeah, move it in a certain direction.
yeah. Okay,
Point out that the numbers underneath the radical sign
right.
must be greater than or equal to 0. And you
Okay.
solve this little equation, this little inequality here, and you can see that X has to be greater than or equal to -3. So it could be equal, and that's why we use a bracket, because it could be equal to -3, but then it goes all the way out to infinity. And that's when we use the open parentheses.
Okay.
Here's a problem I'd like you to think about. I'd like you to do this problem. Given that y equals -3x plus 4, find the value of y. Y is equal to -3x plus 4. But we are told that we want x to equal -5. So -3 times -5 plus 4. And obviously, this comes out to +15 plus 4, and y is equal to 19. And that's it. But look at all the words that had to be used, and just to get this problem. Function notation. This is how this could be written in function notation. F of x. This is written, this is read, f of x. It's not, fx, it's not f times x. This is written. This is how it's spoken. F of x. F of x is equal to -3x plus 4. If this is true, if f of x is equal to -x plus 4, let me just get this away for a moment. Then find it's the same exact problem. See all this? All this writing can really be synthesized and look just like this. F of x equals the function, and then find the value of f of -5. And you just do the same thing. This is what we mean by function notation. And if you want to, you could use f of x. If you want to use g of x, you could use g of x, you could use h of x, you could use q of x, it doesn't matter. Usually we stick to f, g, and h in problems that we'll be doing. Okay. take another example. If f of x equals x squared negative 3x plus 4, find f of negative 4. And I'd like everyone in the class to do that problem right now. If you saw this for the first time, you would say, okay, here's a function that's equal to that. Okay. F of negative 4 means that wherever you see an x, you substitute the negative 4. That's all this means. That's all it means. You see the relationship between these two? Rather than going through all of this that I wrote up here, given that this is it, find the value of y, this is all you have to do. Given the function, find f of negative 4. And you do the exact same thing. You go through it, negative 4 to the second is positive 16. Negative 3 times negative 4 is positive 12 plus 4. You got to know your sign numbers. You know that. You got to know that a negative 4 times a negative 4 is equal to a positive 16. You must know that a negative 3 times a negative 4 is a positive 12. And then you have to know, of course, how to add. Well, actually, you don't have to know how to add, because you do have a calculator. And the calculator is supposed to help you with these things. So, but 16 and 12 is 28 and 32. And the way you write it is f of negative 4 is equal to 32. Anyway, I wanted you to know that. Here's the next problem. If f of x equals x squared minus 3x plus 4. Wow, that looks pretty familiar, right? Find f of 3 plus h. So therefore, I'm going to begin. All right, so the first thing you want to do is take 3 plus h and square it. Now, most people have trouble with that, so therefore, let's do it over here. 3 plus h squared is equal to 3 plus h times 3 plus h. And this is the way you multiply a pair of binomials. See, this is intermediate algebra and pre-calculus, but I'm going back to algebra now just to focus on this. So this is the way you should do it. 3 times 3 is 9. 3 times h is 3h. 3 times h is 3h. And h times h is h squared. And that gives you 9 plus 6h plus h squared. And that goes back here. So you now put 9 plus 6h plus h squared. Is there anybody who has a question about what I just did here? It's pretty obvious, right? You just take each, the 3, and you multiply it by the 3 and multiply it by the h by the 3, and the h by the 8. It's sort of like the distributive property, right? You're taking that 3 and distributing it between the two numbers in there, or letters, whatever. And then I do it this way, and then you add the like terms. Okay, now let's go to the next part. Negative 3 times positive 3 is -9. -3 times positive h is -3h. And then the 4 just is brought along. So this becomes this. Brian, please mute unless you want to ask a question. Brian, Brian, could you mute unless you're asking a question? Okay, now let's combine like terms. Okay, so start at the left, +9 and -9 is 0. Now the h squared, we usually put at the beginning. So right away, you could take that h squared and put it at the beginning. And now you have 6h minus 3h is positive 3h. Okay, so you got rid of the 6h, the -3h, you wound up with 3h. And then there's no other numbers here now, because we did the 9 and the 9 and got rid of them. So just bring along the 4. And the answer to the question, f of 3 plus h is equal to this expression, h squared plus 3h plus 4. Everybody okay here? Okay, next problem. And this is going to actually be a new topic, and I will tell you the topic in just a moment. But first, I'm going to ask you, well, first, let's give in some information. Given f of x equals x squared minus 2x. If f of x equals x squared minus 2x, find f of 5 plus h minus f of 5 divided by h. So given this function, I'm asking you to do this and do that and put it over h. But what do I have to add to this problem in order for it to be valid? There's one more thing I need to put in this problem. What do I need to do?
H can't equal to 0.
Very good. That's necessary, because you can't have a denominator of 0. Okay, so what exactly does this mean? Well, I'm going to do this with you, and then I'm going to let you do the next one on your own. But I'd like to just do this with you. So this is saying, well, f of x is equal to this, but we don't want f of x. We want f of 5 plus h. F of 5 plus h. That's what this is saying. This is the given function, but these are the values you're going to substitute, f of 5 plus h. So 5 plus h squared minus 2 times 5 plus h. Which equals, now, can you do this without me? I mean, can you finish this off? Well, go ahead. From this point, finish off what it's going to be, squaring and then, doing all that stuff. So now the problem is in your hands. So now this is not necessary. If you can go from here to what I'm about to write, that's the best. But if you need to go here first, that's okay. So 5 times 5 is 25. 5 times h is 5h. H times 5 is 5h. H times h is h squared. Minus 10 minus 2h. If you were able to go from here to here, or even better, to here, that would be the best. If you were able to go, and this is what you should strive for, to be able to take a binomial raised to an exponent of 2 and know that this was equal to this. That's what you should strive for. And we'll be doing, quite a few of these. But let's not forget the -10 and the -2h. Okay, now what do we wind up with? Well, as I said, put the h squared first. And there are no other h squares, so we could get rid of that. Now, let's see, the 10h and the -2h is positive 8h. And then, get rid of it, because we're not using it anymore. All that's left here is 25 minus 10 is 15. So f of 5 plus h is equal to h squared plus 8h plus 15.
Good question, Professor.
Yes,
I mean, I got 15 plus 8h plus h squared.
that's fine.
Okay, so it doesn't
But
have to be in that
That's
specific order.
fine, but this is preferable. I mean, if you got what you got, I would never mark that wrong on a test, ever. But I'm telling you that from a from a course point of view, this is what it should look like. Okay,
And then I just have a question, but for this to be right, we need to put it over h, right?
well, I'm not finished yet because.
Okay, I just wanted to make
In other
sure.
words,
Okay.
we did this part, right?
Right, we did the top part first. Okay,
Now I want to do this part,
okay.
and then
And-
we'll put it over,
And
back
then we put
over
it all
the
back
original.
over h. Okay.
And then you also subtract the second answer from the first answer?
Well, let's hold off. Let's hold off.
Okay.
So in other words, we did this, now we're gonna do this. F of 5 equals 5 squared minus 2 times 5. Okay, so I'm again, I start with the original function. And I substitute, it's f of 5, it's not f of, 5 plus h, we did that already. But now it's that, and that's gonna equal 25 minus 10. F of 5 is equal to 15. Okay, now we take the f of 5 plus h, and instead we substitute what we found it to be, which is h squared plus 8h plus 15. Okay, so we took this, we substituted this for that. Now there's a minus sign there, so you got to put that. And then instead of f of 5, we substitute the 15. All over, don't forget, over h. This cancels out with that. That always happens in this type of problem. So if that doesn't happen, if you're doing this problem and you can't cancel these two out, then you've made a mistake. But anyway, what we wind up with is h squared plus 8h divided by h. Now, this can be simplified, and you must simplify it. So what you need to do next is go h squared over h plus 8h over h. So, you're taking a binomial, you're dividing it by a monomial, and that's what this becomes this. And we're left with h squared divided by h. H squared is the same thing, as you know, hopefully, is equal to h times h. So you're allowed to do that. You get h. You're allowed to do that and you're left with 8. And this is the answer to the problem. This is called, let me just go back to the top here. Where was the top? I don't think I have any room for the top. Oh, right by the 4. Okay. This is called a difference quotient. Difference quotient. And for those of you who are going on to Math 301, Calculus 1, this is one of the first topics you'll be doing. And what we just did when we did this was we found what is called the first derivative. That's all we're going to say. I'll let your calculus teacher tell you the rest. But we just found the long way. There's a much shorter way of doing this problem, but this is a long way of finding the first derivative.
What's the shorter way?
No, I'm not doing that. That's calculus. Okay. Anyway, I would like to give you another one. This is a test question. This is not only on the test Thursday, but this is on the final exam. The difference quotient. Very, very important concept. If f of x equals x squared plus 3x, find f of h minus 7 minus f of 7. Now make it at h plus 7 minus f of 7 divided by h, and that's assuming that h is not equal to 0. Okay, and I will give you some time to do this. F of x equals x squared plus 3x. Therefore, you do this. F of x, h plus 7. So that's what goes here. And wherever you see an x, you're going to be substituting h plus 7. H plus 7. And now you work this out. And this becomes h squared plus 14h plus 49. And this becomes 3h plus 21. And simplifying, it becomes h squared, and then 14h and 3h is 17h. And then 49 and 21 is 70. So what we did here was f of h plus 7 is equal to h squared plus 14h, plus 17h plus 70. Anybody have a question about just this so far? Okay, then let's move on to the next one. So now we did this, now we do that. F of 7. F of 7. Well, you know, you could do this if you'd like. If you'd like to put the original function in closer proximity to what you're doing, you could say, well, okay, F of 7 is equal to, well, I started to do it, but I shouldn't. 7 squared plus 3 times 7. Okay, notice the similarity here. F of 7 is equal to 49 plus 21. F of 7 equals 70. Notice the 70 there. Notice the 70 here. There's your check that you're doing everything according to what you're supposed to be doing. When that number is different from this number, you have a problem somewhere. So if you're doing this on a test or whatever, these two numbers have to be the same. So now we go back to the original difference quotient.
But
And
what if
Instead
the,
of f of h plus 7, we write h squared plus 17h plus 70. And then minus, and f of 7 is 70. Is there a question?
yeah, what if the question tells you to, the second f that you need to find is different than 7? Like what if you put an 8 there? Then you can't cancel it.
It'll always look like this.
Is there a reason for that?
Yeah, because that's part of the process of finding the first derivative using the process known as finding the difference quotient. So anyway, here we go. H squared, so this drops out. That's the whole point. And then h squared plus 17h over h. And then that equals h squared over h plus 17h over h. This is equal to h. So this is equal to this. And this is equal to that. And that's the answer to the question.